Introduction to Normalization. Dear learners, as you know that a database is an integrated collection of data, the large tables need meaningful subdivision into smaller tables. These small tables are easy to administer and control for efficient processing and storage. The normalization is the process by which a table is splitted into smaller meaningful tables. Dear learners, here an important question arises. Why a table needs normalization? The splitting of a table is evaluated in terms of three anomalies. These are insert, update, delete. Let us now discuss each in more detail. Insert anomaly. It is the problem of adding new row in a table for one or other reason. For example, consider table course as shown. The analysis of the table course shows that it is a valid table as it satisfies all basic conditions such as the table has a primary key which ensures that each row is unique and each column is unique. Dear learners, though it is a valid table, but let us see what will happen if it is required to add a row in order to define a course with course code CS3441 entitled Computer Networks with the assumption that this course is not registered by any student. This can be done only if providing values of primary key attribute that are registration number and course code, but the value of registration number is missing as the course is not yet registered by any student. Thus, course data cannot be defined unless registered by a student. Therefore, the course table has insert anomaly. Update anomaly. It is the problem of updating a row in a table for one or other reason. For example, in the table course, if it is required to update the course title, database 1, then it needs multiple updates due to redundancy. Thus, the course table has the update anomaly. Delete anomaly. It is the problem of deleting a row or rows from a table for one or other reason. For example, in the table course, if it is required to delete the course registration of student with registration number R3 for course CS3413 data communication, this will result in the deletion of entire row and will also delete the course data CS3413 and data communication. Thus, the table course has the delete anomaly. Dear learners, a table with any of the anomaly discussed is considered to be a poor table. Therefore, such tables need some treatment. The normalization is a technique used to control these anomalies discussed earlier. Dear learners, there are two stages of normalization. These are simple normal forms, higher normal forms. Most of the business applications need simple normal forms. Therefore, only simple normal forms are discussed here. Dr. E.F. Codd proposes the simple normal forms. There are three stages of simple normal form. These are first normal form, second normal form, and third normal form. Let us discuss each in more detail. First normal form. A table is said to be in first normal form if there is no multi-valued attribute. For example, consider the table student as shown. The sample rows show that each student has one value of name and phone number. Dear learner, the table student is in the first normal form because there is no multi-valued attribute. Let us modify business rule for the table student as a student may have many phone numbers. The sample rows are shown as analyze the table carefully for validity. Do you think this is a valid table? Surely not, because it violates an important rule of database tables, that is, there must be primary key. The existence of multi-valued attribute phone prohibits the primary key definition. This problem is handled by two ways. These are eliminate the multi-valued attribute by defining composite key as shown. Now the table shown as is a valid database table as there is a composite key. But this method of eliminating multi-valued attribute is not effective and has a serious drawback that it introduces the update anomaly due to redundancy. For example, in the table as shown, the name of student, that is Arsalan, is stored redundantly. Let us discuss second solution of the stated problem. Extract multi-valued attributes from given table and place them in a separate table such that the newly created table must have a composite key. This composite key must have the primary key of original table as a part. This means that the original table, which is not in the first normal form, shall be decomposed into two tables, such that multi-valued attributes are placed in one table and single-valued attributes are placed in another table. Dear learners, a table with multi-valued attribute may also be converted into first normal form by replacing the multi-valued attribute with an atomic attribute for each value. For example, the table student with the multi-valued attribute phone as shown. It is converted into first normal form by replacing the multi-valued attribute with atomic attributes for a number of phone values as shown. This approach should be avoided for these reasons. If new phone number is required to be added for a given student, this may be done only by adding new column to the table. This brings structural changes in the table. Therefore, each time a new value is to be added, structural change of the table is required. It is not necessary that a given student must have defined number of phone numbers. Therefore, blank spaces may be stored against the phone number for which there is no value. This leads to storage wastage. Functional dependency. The functional dependency is the relationship between attributes of a table. It determines how the values of one attribute A determine the value of another attribute B in table T. Graphically, it is represented as shown. It is important to note that the attributes on either side of the arrow may be more than one as shown. The attributes at left side of the arrow are called determinant because it always determines the value of each attribute at right side of the arrow. For example, consider the table student as shown. Look carefully. The value of attribute name could be determined by knowing the value of attribute registration number. Similarly, knowing the registration number of a student, the value of attribute city could also be determined. This is shown graphically as. Dear learners, now it is time to discuss various types of functional dependency. These are partial dependency, full dependency, transitive dependency. In addition, there are other types also, which are beyond the scope of current discussion. Therefore, only stated dependencies are discussed here. Partial dependency. It is the dependency where non-key attributes are functionally dependent on any part of the composite key. For example, consider the table employee as shown. Dear learners, let us analyze the table. Knowing the value of key attribute employee ID, the value of non-key attribute name can be determined. Thus, the non-key attribute name is partially dependent on composite key. This dependency is represented graphically as shown. Similarly, knowing the value of key attribute software ID, the value of non-key attribute software title can be determined. Thus, the non-key attribute software title is partially dependent on composite key. This dependency is represented graphically as shown. Full dependency. It is the dependency where non-key attributes are functionally dependent on complete composite key. For example, consider the employee table once again and look carefully. The value of non-key attribute hours worked can be determined only if knowing the values of all key attributes, that are employee ID and software ID. Thus, the non-key attribute hours worked is fully functionally dependent on composite key. This dependency is represented graphically as shown. Transitive dependency. It is the dependency where non-key attributes become determinant of other non-key attributes. Dear learners, look at this table carefully. The value of non-key attribute date of completion could be determined by knowing the value of non-key attribute project ID. Thus, the non-key attribute project ID becomes determinant of another non-key attribute date completion. This is transitive dependency and is represented graphically as shown. Normal form. A table. Second normal form. A table is said to be in second normal form if it is in first normal form and there is no partial dependency. Dear learners, there are two possibilities for existence of partial dependency. Each one is treated in different way. These are along with full dependency, without full dependency. Let us discuss each in more detail. A table having partial dependency along with full dependency is decomposed as: convert each partial dependency into a new table. The determinant of each partial dependency becomes the primary key attribute of corresponding table. The full dependency is converted into another table. Dear learners, look at the employee table. Do you think the table is in the first normal form? Yes, very good. The table is in the first normal form because there is no multi-valued attribute. Let us evaluate the table for various anomalies. Here is the analysis. New software cannot be added until an employee is assigned to it. Similarly, new employee cannot be added until software is not assigned to that employee. Thus, we are forced to stop adding rows, so the table has insert anomaly. Multiple updates of a software title are needed as it is redundantly stored. Similarly, multiple updates of an employee name are also needed as it is redundantly stored. Thus, the table has update anomaly. By deleting the employee Fawad Rauf, the data of Visual Basic software is also deleted as there is single employee working with it. Thus, the table has delete anomaly. Dear learners, the table is in the first normal form, but still it has all anomalies. Let us find out the reason. Yes, there is a partial dependency along with full dependency. Now, let us find out the solution. The solution is that first, identify the partial and full dependencies as shown. Then, apply the decomposition rule as the partial dependency as shown is converted into employee table. The determinant of this partial dependency, that is attribute employee ID, becomes the primary key attribute of employee table. Similarly, the partial dependency as shown is converted into software table. The determinant of this partial dependency, that is attribute software ID, becomes the primary key attribute of software table. The full dependency as shown is converted into work table with composite key attributes that are employee ID and software ID. Dear learners, let us now compare the employee table before splitting as shown with the newly created tables employee table as shown, software table as shown, and work table as shown. The new employee could be easily added in the newly created employee table, which is not possible without software in original employee table. The new software could be easily added in software table, which is not possible without an employee in original employee table. The software title update in software table does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. Similarly, the employee name update in new employee table does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. The employee deletion from new employee table has no effect on software table, while software data is deleted on deletion of an employee from original employee table. But an employee deletion from new employee table and software deletion from software table has effect on work table. This issue is controlled by applying integrity rules which are beyond the scope of current discussion. Dear learners, let us now discuss second possibility of existence of partial dependency, that is without full dependency. A table having partial dependency without full dependency is decomposed as each partial dependency is converted into a new table. The determinant of each partial dependency becomes the primary key attribute of corresponding table. The composite key attributes of original table are placed in another table with a composite key, which comprises the primary key attribute of each new table. Consider the employee table with an assumption that a given job may be assigned to only one employee, but an employee may be assigned many jobs, as shown. Dear learners, the table is in the first normal form because there is no multi-valued attribute. Let us evaluate the table for various anomalies. Here is the analysis. New job cannot be defined until not assigned to an employee. Similarly, new employee cannot be defined until a job is assigned to that employee. Thus, we are forced to stop adding rows. Thus, the table has insert anomaly. The name update of an employee need multiple updates as it is stored redundantly. Thus, the table has update anomaly. If it is required to delete the employee named Daniel Daud, this leads to the deletion of job J3 data also. Thus, the table has delete anomaly. Dear learners, the table is in the first normal form but still has all anomalies. The only reason is the existence of partial dependency without full dependency. As discussed earlier, first identify the partial dependency as shown. Then apply the decomposition rule as the partial dependency is converted into a new employee table. The determinant of this partial dependency, that is attribute employee ID, becomes the primary key attribute of new employee table. Similarly, the partial dependency as shown converted into job table. The determinant of this partial dependency, that is attribute job ID, becomes the primary key attribute of job table. The composite key attributes of employee table before splitting, that are employee ID and job ID, are placed in employee job table as shown. Dear learners, let us now compare the original employee table before splitting as shown with newly created employee table as shown, job table as shown, and employee job table as shown. A new employee could be easily added in newly created employee table, which is not possible without job in original employee table. A new job could be easily added in job table, which is not possible without job in original employee table. An employee name update in new employee table does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. Similarly, the update of job description in job table does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. The employee deletion from newly created employee table has no effect on job table, while job data is deleted on deletion of an employee from original employee table. But the deletion of employee from new employee table and deletion of job from job table has effect on employee job table. This issue is controlled by applying integrity rules, which are beyond the scope of current discussion. Third normal form. A table is said to be in third normal form if it is in second normal form and there is no transitive dependency. Dear learners, it is now clear that if a 2NF table has any of the insert, update or delete anomaly, then there is transitive dependency. The table is refined to 3NF by separating each transitive dependency and convert it into new tables. The determinant of each transitive dependency becomes primary key attribute of corresponding table. There are two possibilities for existence of transitive dependency. These are where the determinant has single attribute, where the determinant has multi-attribute. Let us discuss each in more detail. Single determinant attribute. If a 2NF table has a transitive dependency where the determinant has a single attribute, then the transitive dependency is converted into a new table. Dear learners, the transitive dependency is not restricted to one. Thus, each transitive dependency is extracted from original table and converted into a new table. The determinant of each transitive dependency becomes the primary key attribute of corresponding table. Add the primary key of each table resulted from transitive dependency as foreign key in original table along with all remaining attributes. Consider the table employee once again. As shown, look carefully at the table. Is the table in the first normal form? Yes, the table is in the first normal form because there is no multi-valued attribute. Now analyze it for second normal form. It is very easy as there is no composite key. Therefore, there is no chance for existence of partial dependency. Thus, the table is in the second normal form. But let us evaluate the table for various anomalies. New project cannot be defined until an employee is not assigned to the project. Thus, the table has insert anomaly. The update of project completion date need multiple updates because it is stored redundantly. Thus, the table has update anomaly. The deletion of an employee may result the deletion of project data also if there is single employee in that project. Thus, the table has delete anomaly. Dear learners, the table is in the second normal form but still has all anomalies. The only reason is the existence of transitive dependency as shown. Now let us resolve these anomalies. This second normal form table needs decomposition as the transitive dependency as shown is converted into project table. The determinant of this transitive dependency, that is attribute project ID, becomes the primary key attribute of project table. Add this primary key to employee table as a foreign key along with remaining attributes. Dear learners, let us now compare the employee table before splitting as shown with newly created employee table as shown and project table as shown. New project could be easily added in table project, which is not possible without an employee in original employee table. The update of project completion date in table project does not need multiple updates as there is no redundancy, while need multiple updates in original employee table. The deletion of employee from table employee has no effect on table project, while project data is deleted on deletion of an employee from original employee table. The deletion of project from table project has effect on table employee. This issue is controlled by applying integrity rules, which are beyond the scope of current discussion. Let us now discuss multi-attribute determinant in transitive dependency. Consider the table route as shown. It stores the distance in kilometers of different routes along with driver identification. Dear learners, the table is in the second normal form as there is no multi-valued attribute and no partial dependency, but still the table has these anomalies. New route cannot be defined until a driver is not assigned. Thus, the table has insert anomaly. Deletion of driver data may result the deletion of route. Thus, the table has delete anomaly. The reason of all these anomalies is the existence of transitive dependency, but this time the determinant is composed of multi-attributes that are origin and destination. The table route is to be refined to third normal form by adopting the same decomposition rule as discussed earlier. The transitive dependency as shown is converted into distance table. The determinant of this transitive dependency, that is attributes origin and destination, becomes the composite key attribute of distance table. Add this composite key to driver table as a foreign key along with remaining attributes. Dear learners, let us now compare the route table before splitting as shown with driver table as shown and distance table as shown. The new route, that is origin and destination, could be easily added in distance table without driver information, which is not possible in route table. The deletion of a driver from table driver has no effect on table distance while route data is deleted. If driver data is deleted from route table, The deletion of root from distance table has effect on driver table. This issue is controlled by applying integrity rules, which are beyond the scope of current discussion.